All right, so my work is using a municipal solid waste collection model to estimate costs and emissions from collection. And the idea of this is that collection has a really big impact on the total fuel consumption of managing municipal solid waste, a larger amount even than other steps along the way. So we've developed a process-level life cycle model to estimate the fuel use and cost from municipal solid waste collection for residential, multifamily residential, and commercial waste, which allows the user to specify all types of details about the process, from how frequently waste is collected and how many separate streams are collected, how many days per week collection services are offered, and so on. And so we've used a lot of empirical data to develop a set of default model parameters to allow us to estimate fuel use and costs. So some of the things we've been looking at are looking at our model predicted fuel consumption and comparing it with some of the data we've gotten from operational collection. And we found that we've been able to estimate pretty well how much fuel would be used by a similar system to an actual real-world operation, and that when we're able to refine the fuel efficiency estimates, that we can better predict what type of fuel use would be compared to the real-world values. We've also looked a little bit at model sensitivity. This chart shows the fuel use, cost, and the number of trucks as how they vary with changing things such as fuel efficiency, the time spent at each house, the distance between houses. And what this allows us to do is to refine our estimates of our input data and better predict our output values. So this model can also be used within an integrated framework to estimate the entire emissions and costs associated with solid waste management from curb to final disposal, which can give some interesting insights into how best to manage different waste streams. But some things that I'm currently working on are looking at the sensitivity of the model to fuel efficiency and considering the switching fleet vehicles from diesel to natural gas. So there's some somewhat conflicting literature about how diesel and natural gas compare when you consider things like production, distribution, and storage of natural gas. So what we're interested to do is looking at how the emissions profiles vary and how fuel efficiency varies between natural gas and diesel vehicles, and get an idea of where natural gas outperforms diesel and how robust that recommendation would be. So that's something we're working on now.